All right, so we're going to look at a couple different things today. First, a hypothetical scenario. Okay. Understanding the big picture of determining if something is a function is whether or not we can predict the output. We're going to have a fun little hypothetical here, testing your art skills. Drawing a soda machine. Okay, and it's got 5 buttons. All right. First 2 will be Coca-Cola. Throw a Sprite in there. A Diet Coke. And how about a Dr. Pepper? So our input's going to be whatever button we push. And our output's going to be whatever soda comes out. So we're going to go over a couple of scenarios here. Okay, to determine if the machine is functioning properly. If it's functioning properly, okay, then we'd say that the function works. So scenario 1 here, let's say Miss Lum pushes the Sprite button and gets a Sprite. Okay. Then comes back later. Pushes the Sprite button. But this time she gets a Coke. All right, so obviously common sense will tell you machine's not working properly, right? First time she pushes the Sprite button, she gets a Sprite. Next time she comes back, pushes the Sprite button, looking to get another one, and this time a Coke comes out. Okay, Can she accurately predict what's going to happen when she pushes the Sprite button? She cannot. So this would not be considered a function because we cannot predict what happens when we push the Sprite button. Okay, not a function because we don't know, we cannot predict what our output is when our input is the Sprite button. All right, next scenario. Mr. Gale pushes the Coke button, the first Coke button, excuse me. On odd days. And then the second Coke button on even days. But he always gets a Coke as an output. Okay, so he's got two different inputs, the first Coke button and the second Coke button. Okay, but he can always predict what's going to come out. It doesn't matter which button he pushes. It's always going to give you a Coke as an output. So we would say this is a function. Because he can always predict what soda will come out. All right, last scenario. So Mrs. Armis pushed the Dr. Pepper button. And got a Sprite. Later in the day, Mrs. Gonzalez came by. Pushed the Dr. Pepper button again. And she also got a Sprite. So a little confusing here because we're kind of getting the wrong product. However, if we're consistently always getting the wrong product, then we should be able to predict what's going to come out. So we will say this is a function because we can predict by pushing the Dr. Pepper button. We will get a Sprite. Okay, so now we're going to take a look at what does that look like on a graph. Okay, so remember a graph this is your x-axis. That is where x values go, which are inputs. Okay, this is our y-axis where y values go. Okay, our outputs. All right, so it's going to be helpful to just keep that in mind.
She said, hey, what about my blue tape? Is that hers too?
Yeah, I gave you both of them. Oh my gosh.
She didn't even keep that.
No, bring it back over there.
You didn't even clear, dude.
I handed you both of them. So we're going to go over a couple of examples. Start with these two for now. So on the first one, we just have points on a graph. Okay. Easy way to kind of think of this is, well, we could just convert this into a table and then we can kind of look at it that way. So let's say we have our X and our Y values. First one is at -2, 1. Next one's at -1, 3. 0, -1. 1, 1, and then 2, 0. Okay, so looking at just the table now, input of -2, 1, none of our inputs here, okay, duplicate. Okay, so we know this is going to be a function because nothing duplicates over. If we had one that said -2, 0, then that'd be an issue. Okay, but all inputs, we would say, yes, this is a function because all inputs have a unique output. On the second one, it's a little bit different. We got this curly line. Okay, and at first glance, maybe it's hard to tell. Okay, but if we just isolate a single input, let's say 0, okay, on the x-axis. So we have an input here of 0. We have an output of 0. We have an output of somewhere around 1, another output up here, another output down here, another output down there. So the input of 0 is going to give us 5 different outputs. That is not good. Okay. So no, this is not a function. And we'll say because the input of 0 has 5 different outputs. Okay, 5 is a lot. It could be as many as just 2 different outputs, and that still wouldn't work out. Okay, so the easiest way to tell with graphs, and this isn't always going to be an acceptable answer, okay, but it's what's called the vertical line test, where essentially what you're doing is you're taking a vertical line like so, and you're running it across your graph. And if your vertical line ever touches the graph in more than one place, that's not good. So as we go through these points here, okay, my vertical line, my little card here, is never touching 2 dots at the same time. As I move over here to this squiggly line, I guess I'll call it. Okay, once I even get to right here, okay, you can see it's touching here, okay, as well as here. That's not good. Okay, and as I go throughout the graph, it's clearly touching the graph at multiple places. Okay, so the vertical line test can at least give you an idea on whether or not we're touching the graph in more than one place. Okay, and if so, we know that one input has more than one output. Take a look at a couple more pretty common graphs that you'll see a lot of. Okay, so first one's kind of a cubic function here. If I took a vertical line and I go across, okay, am I ever touching the graph twice at the same time? No, even though it gets a little straight right here, it's still moving to the right. Okay, so this is a function. And again, we can just say because all inputs have unique outputs. Okay, so you have a cubic line. Even if you had a diagonal line that goes straight like that, that's always going to be a function as well. Okay, if you had a parabola, like this one would still work out. This one's always going to work out. These types are always going to be functions. Okay. Cubics are always going to be functions. Circles, on the other hand, are not, right? Pretty easy. I take my vertical line, okay, touching the graph here and here, not good. Okay, so if I had even if I had an input of 0, touching the graph at 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, -6. Okay, so the input of 0 is going to give me an output of 6 and -6, which is not good. So again, no. You don't necessarily have to give an example. You can just say not all inputs have unique outputs.